All right, so today's lesson is going to be on multiplying polynomials. So you want to write this down as your topic for today. You also want to write down your learning goal, which is I will be able to multiply binomials times binomials, which is a 2 by 2, and binomials times trinomials, which is a 2 by 3. So make sure you have your topic and learning goal written down in your notebook so that you know what these problems are going for when you're practicing in class or studying for an assessment. So if you need to, go ahead and pause and make that happen. So let's do a little bit of review from Algebra 1, which is the law of multiplying powers or the product of powers. And basically that law says that you are going to add the exponents if they have the same base. And another way to remember base is basically if they have the same letter, you are going to add the exponents. So here we have x to the third times x to the fourth, which if I write that on an expanded form, x to the third is x times x times x. X to the fourth is, of course, 4x's. And each of these x's has an invisible one as the exponent. So I'm just giving you a little background on why this law is the way it is. When you look and you add up the 3x's plus the 4x's, each of them having an invisible one as the exponent, you get 3 plus 4, which is x to the 7th. Okay, so that is the law of product of powers or multiplying powers. Add the exponents if they have the same base or the same letter. So let's take it up a notch in this review of our Algebra 1. And it says use the product of power law to now multiply this. And if you notice, we have x squared y to the 5th times x to the 7th y to the 9th. How would we attack this? Well, again, same letters. We're looking for same letters because we're going to deal with those separately. So I've marked my x's with the color red, and I have marked my y's with the color green. You should have a couple of colors with you, whether you have a pen or a pencil, some colored pencils, crayons, markers, or even highlighters just to help you differentiate the difference between your x terms and your y terms. But I have x squared and x to the 7th, and basically that's the same thing as saying 2 plus 7. And for my y's, I have y to the 5th and y to the 9th, so I add those exponents because they have the same base. And my final outcome should be x 2 plus 7 is 9, and y, and I've got 5 plus 9, which is going to be 14. So that is using your law of product of powers and multiplying powers. Continuing on a little bit into our Algebra 1 review of this, we're going to now look at the box method for multiplying polynomials and the distributive method for multiplying polynomials. You did see this in Algebra 1, so this will be a quick review. If you prefer the box method, then it should look familiar on the left side of your screen. And if you preferred the distributive method, that's where we draw our arrows, you should be looking more towards the right side of the screen. For this particular example, I am going to show both methods, but when we go deeper into our practice, I will just be focusing on the distributive method, but feel free to do whichever method floats your boat. Now notice at the top of the screen here, it's a checklist for multiplying our polynomials. First, you want to multiply the signs. So check for your positives and negatives and make sure that you're giving your term or your answers the correct signs. Next, you're going to multiply the numbers, and then finally, you're going to multiply or the exponents, which means if they have the same letter, you're going to add the exponents if they have the same letter. So you're got to do parts 1, 2, and 3 in order to make sure that your answers come out correctly. So let's look at this a little more in detail. Let's see what happens when we actually do the multiplication. you should have ended up with x squared minus 7x plus 3x minus 21. Now at the top of the screen it does say no matter what method you use, you should still end up with the same term after multiplying. So whether you're a box method or distributive method, your terms will be the same. The only difference is in box method, your terms come out in a box. In distributive method, yours are not in a box, but you can still compare your work with another person that is doing a different method, because when you multiplying those same terms, you should still get the same outcomes. So remember, x times x is x squared, and then we did x times negative 7, which was negative 7x, and then you did 3 times x, which is 3x, and then negative 7 times 3, which is a negative 21. Moving forward, the last step here is to find like terms and combine those with the same variable. So remember, variables are letters and the same exponent. So like terms have two parts to it. Has to be the same letter and same exponent. Okay, both of those have to match. In this case, the only things that matches are negative 7x and positive 3x. So notice how I highlighted these using a different color, so I'm showing what's changing. Make sure in your notebook you are using at least 2 different colors. If you have more than 2, awesome, great, but at least 2 different colors so that you're able to see what is actually changing. Okay. And our last step here is just our final answer. When you combine a negative 7 and a positive 3, you do get a negative 4. So this is what our final answer would come out to be. So that was pretty much our review. Here on this slide, it's the different rules for multiplying polynomials using box method or distributive method. You can go ahead and pause this video, and whichever method you prefer, I would highly suggest that you copy down the steps for your preferred method so that you have these to go back and look at when you're doing your homework or you're practicing in class or you're studying. You have these to kind of guide you. And yes, you still need to write that part that's highlighted where it says multiply the signs, the numbers, and exponents, because no matter which method you use, you do have to make sure you're doing the multiplication 3 different ways in order to get the right answer for each individual term. So again, go ahead and pause, copy down your preferred steps, and then move forward. So let's get into some practice here. will always be slides that I will do with you. So we have 5x minus 4 and squared. Okay, there's a squared outside of those parentheses. So just to kind of give you some background on this, if I were to write 5 squared, you would know that 5 squared is the same thing as writing 5 times 5. So if I have 5x minus 4 squared, that is saying that I'm going to take this term and I'm going to write it out that many times. So to get my actual problem, I would write 5x minus 4 twice. So that is how you set up your problem when you have it written like this. Now, again, if you prefer box method, go ahead and draw out your boxes. I'm going to focus on distributive method for the video, but you should still end up with the same terms and the same answers when you multiply, even if you are doing the box method. So we're going to take this first 5x, we're going to multiply it times everything in the second set of parentheses, and 5x times 5x should give me 25x, but don't forget that you have to add those exponents, so it should be squared. Now, signs, positive times a positive is a positive, 5 times 5 is 25, and x times x, don't forget that there's an invisible 1 for each of these, x times x, 1 plus 1 is 2, that's how I ended up with x squared. Now I'm doing 5x times negative 4. Well, that's a positive times a negative, which is a negative. 5 times 4 is 20. And I cannot throw away my x, even though there's no other x. I still have to keep that x. Now that we've done that part, we're going to come and we're going to do it for this negative 4. So we're going to multiply this negative 4 times each of the terms in the second set of parentheses. So I have negative 4 times 5x, so that's a negative times a positive is a negative, and 4 times 5 is 20, and then x times x, that's x, 1 plus 1 is 2, so it should be x squared. Okay, so I totally lied. Teachers make mistakes too. Sorry, there's no x with the 4. It's just x times no x is just x, so it should just be a negative 20x. That was my mistake. Then I'm doing negative 4 times negative 4. So a negative times a negative is a positive. 4 times 4 is 16. And there are no variables for us to deal with. So from here, we are now going to take care of our like terms, things that actually go together. So remember, like terms have to be the same variable, so same letter and same exponent. So I do have x squared and x's, but these other x's don't have an exponent of 2, so they're not like terms with the x squared term. The only like terms we have are negative 20x and the other negative 20x because they both just have x. So I bring down what's not changing. Negative 20 minus 20 is going to give me a negative 40. Keep my variable. And then I'm not doing anything with the 16, so I just bring that down. And that is my answer. So pause it, copy down what you still need to copy down, and move on to the next slide. All right, so now that we've done a we do, you can see at the top of this slide, it does say you do. So pause the video, pause the video, and try it on your own inside of your notebook. So you're going to pause the video, and you're going to do your preferred method, whether it's box or distributive. You're going to try this on your own. So pause the video, give yourself about 3 minutes to give it your best shot, and there you go. Okay, so now that you've unpaused the video and you're ready to go over this, you see that when you multiplied it out, you should have gotten these 4 terms. I did color code them for you, so you can see. I highly suggest you using multiple colors in your notes so that you can see what's changing and how we're getting the different parts. So we multiplied everything out. Our next step now is to mark our like terms. So the like terms we had were 6y and negative 3y, and when we combine those we get a positive 3y, so this is our answer. Pause as needed so that you can make any corrections in your notebook. Make sure you identify any mistakes you've made so that you don't make those same mistakes moving forward. Okay, so we're going to do another redo. Now this one is a trinomial times a binomial, so a 3 by 2 or 2 by 3. Multiplication order doesn't really matter. So we're going to knock this out together. Okay, so I'm going to take the first term, which is a 3w squared, and I'm going to multiply it times every term in the second set of parentheses. Okay, so remember signs, numbers, and then deal with your exponents. So positive times a positive is a positive, and 3 times 4 is going to be 12. And then I'm going to bring it down a little bit because I need more space. And then w squared times w. Don't forget your invisible 1 for your exponent right there. So 2 plus 1 is going to be an exponent of 3. When we do 3w squared times negative 5, a positive times a negative is a negative. 3 times 5 is going to be 15. And w squared times no w is still going to be w squared. Okay, that's not going to, exponent's not changing there, but you can't throw it away. Now I'm going to do the second term times everything, and I'm going to use red. So again, make sure you're using multiple colors. When I multiply this, a negative times a positive is a negative. 4 times 4 is 16. Oh, I have another invisible 1 here. So I have w, and 1 plus 1 is going to be 2. And then I come back and I do negative 4w times negative 5. So I have a negative times a negative, which is going to be a positive. And then 4 times 5 is 20. W times no w is still w. I can't throw that away. And notice I'm not done. I am not done. I actually still have one more term that I have to do. And so I am going to multiply this positive 2 times everything in the second set of parentheses. So I'm going to change my color again just to kind of help out with visual purposes. So a positive times a positive is going to be a positive. 2 times 4 is 8. And no W times W is still W. And moving on to 2 times -5, a positive times a negative is going to be a negative. 2 times 5 is 10. And there's no W's for us to worry about. From this point, we're going to mark our like terms, and because it was a trinomial times a binomial, we're going to have, in this case, more than one set of like terms. So see if you can identify the like terms before I do. Remember, like terms, same variable, same exponent. So we've got these here, the W squareds, and then we also have the W's. Make sure you're including the sign that's in front of the numbers when you're marking like terms, because you need to know what integer rules you're using, or you need to know what signs you need to punch into your calculator, whichever you're utilizing. So combining these like terms here, bing, bada, bang, bada, boom, bring down what we're not using. When we get our W's, a -15 minus 16 is going to give us a -31x squared. And then our just W's, 20 plus 8 is going to be a positive 28W. And then we're going to bring down this -10. Make sure that you're writing your final answers in standard form. Make sure you're writing your final answers in standard form. There's no more like terms, so that's our final answer for this one. So pause the video as needed so you can catch up on anything, or rewind as needed. And you already know what's coming up next. Yeah, you're going to have to try this on your own, silly. Okay, so now it's time for another you do. All right, so go ahead and pause the video and try this in your notebook. Please make sure you're utilizing your colors. Maybe set a timer for about 3 minutes. Give yourself about 3, no more than 5 minutes to try this on your own. So pause the video, pause the video. So again, we have a 2 by 3, so a binomial times a trinomial. And we're taking that 5c, we're going to multiply it times the 3 terms in the second set of parentheses. And this is what we should have gotten when we did that. So next, we're going to take that -4, and we're going to multiply it times all the terms in the second set of parentheses. And when I did that, I should have gotten these terms. Double check your exponents. Make sure you have the correct exponents, because you have to make sure that you're adding those invisible ones. Remember, each of those C's did have an invisible one. Our next step here is to combine our like terms. But first, we have to identify what are our like terms before we can combine them. And in this case, we have 2 sets of like terms, our C squareds and our regular C's are like terms. You should have been utilizing colors. If you don't have colors, you also could utilize different shapes to show which ones belong together, but you should not have all 4 terms circled or all 4 terms boxed, because now you don't really know what's going together. And once we combine like terms, this should have been your final answer in standard form. And we know we're done because there's no more like terms for us to combine. So wonderful job on today's lesson. Go back and review anything you need to review, and we'll see you in class.